So today in this video we're gonna talk about enthalpy change for chemical reactions, or it could be phase transformation also. So the condition is one phase must be gaseous and the temperature should be constant over here. So let's see the enthalpy term that is valid for all cases. H equals to U plus PV. So since we are considering gaseous phase, one phase must be gaseous, so we can use the ideal situation here. We are assuming the ideal gas situation here. So we could write PV equals to nRT also. So H equals to U plus nRT. Now we try to differentiate it by both of the sides, then it becomes dH equals to du plus, and we know the temperature is constant over here and the R universal gas is constant, so N must be changing over here, so it is RT dN. The integral is over N. So now if we integrate this term, dH equals to integrate out du plus RT integration of dN. Now when the reaction is happening, so we may write it as delta H equals to delta U plus RT delta N of gaseous state, RT delta N G. Now we know what is delta N G over here. Whenever we are talking about a chemical reaction, so delta Ng means total number of moles of gaseous product minus the total number of moles of gaseous reactant. So we are not talking about like a gas is escaping from the container and delta Ng like final moles we have taken minus initial moles. If we are talking about a chemical reaction, the delta Ng value we are taking number of moles of gaseous product. We are talking about gaseous products only. Negative of minus number of moles of gaseous reactant. So let's see an example. We have a reaction to hydrogen in gaseous state, oxygen in gaseous state, forming H2O water in liquid state. Now what is the value of delta Ng over here? So we see the how many number of moles of gaseous products are there. We don't have any gaseous state product, minus reactant. How many moles of reactant? 3 moles. So delta Ng value comes out to be negative of 3. Now if we talk about this equation, 2HI in gaseous form is forming dihydrogen in gaseous state and I2 in gaseous state. So what could be the value of delta Ng? We know it is gaseous product minus gaseous reactant. So 2 minus 2 moles of gas and 2 moles of reactant, that is 0. Like if we talk about the equation 2 ammonia, that is forming N2 in gaseous state plus 3H2 in gaseous state. So delta Ng here comes out to be product. How many gaseous product? 4 minus 2, that is comes out to be negative of the 2 plus 2. So when we talk about, we have delta Ng equals to 0. In that case we have delta H will be equals to delta U. Now if we look like there is a phase transformation, like in X we have a substance that is converting from liquid to gaseous form, or X is converting from solid to gaseous form. So what is the value of delta Ng? In both cases delta Ng comes out to be 1. Now if we talk about the phase transformation, like X in gaseous form is converting into X in liquid state, and X is gaseous form is going into X in solid state. So there the value of delta Ng that will come out to be negative of 1. Now if we see a different case where X in solid states is going into X in liquid state, and X in liquid state is going into X in solid state. So here we cannot use delta H equals to delta U plus delta NGRT. This equation can never be used here. Why? Because we don't have any we have, first of all we have to consider the equation H equals to U plus PV, that is valid for all. Now if we have used the PV equals to nRT over here. We have replaced the PV as nRT. We replace PV as nRT when we consider it as an ideal gas, when gas is an ideal. So we know there is neither any gas. If there is gas, we generally assume it as ideal gas until unless it is not mentioned that is a general gas or real gas. So here it don't have any gas. So the gaseous delta H equals to delta U plus delta NGRT is not valid over this situation, over this phase transformation. So that is the basic of the enthalpy change of the reaction when there is a phase transformation and the temperature is assuming the constant over here.